Unit 1, Lesson 4 vocab video. Today's vocab will be adjacent angles, complementary and supplementary angles, linear pair, and vertical angles. Adjacent angles. Adjacent angles by definition are two coplanar angles that have a common side, a common vertex, but no common interior points. So there's your definition. Drawing them. Your draw example would be one right here. When we talk about adjacent angles, are angles that have a common vertex. Notice angle 1 here in green and angle 2 here in red both have a vertex right here. I could call it point A. But they have a common vertex, a common side. Notice that the red and the green sides are butting up against each other, but they have no other common points. So 1 and 2 are next to each other, they're directly touching, they're sharing that vertex, and they're sharing that side. This example over here really isn't an example because angle 3 and angle 4, while they have part of a side in common, need to have an entire side in common, and their vertexes are in two different locations. Vertices are in two different locations. When we talk about notation, angle 1 and angle 2 are adjacent, works fine. We've talked about naming angles by using letters. I could say angle ABC and angle CBD are adjacent. There's no special symbol other than an angle symbol, but you're going to need to use the word adjacent. Next two, maybe review from prior courses. Complementary and supplementary are angles that add or sum to 90 degrees and angles that sum or add to 180 degrees. Here would be an example for you to draw. We could say that angle 1 and angle 2 are complementary. Same thing with supplementary. Angle 1 and angle 2 are supplementary. There is no special symbol other than just using the word complementary and supplementary. A word that you will very often see with complementary and supplementary would be complement. Angle 1 complements angle 2. Angle 1 is the supplement of angle 2. May see that word in there as well. I just want to point out for a moment that when you're drawing your example, it may not be a bad idea to jot this down as well, but angles don't always have to be adjacent. Very often you think complementary and you think right angle, which I agree. They're adjacent, they share this vertex, they share the common side, but I could separate these angles too. In order to be complementary, the measurement of two angles needs to add up to 90 degrees. It doesn't say anything about their touching or their location. So I have angle O, and I guess they're both angle O. That's not going to work out really well. Angle AOB and angle POQ are complementary as well because when you add them up, they equal 90 degrees. Over here, I'm going to call this one angle B, and I'm going to call it angle C. Angle B and angle C are supplementary because when I take angle B and add it to angle C, it ends up equaling 180 degrees. Might not be a bad idea to draw the diagram for both, or at least write down for yourself that they're not always adjacent. Lastly, the final two, and these are used most often throughout the course, vertical angles and linear pairs. Vertical angles and linear pairs are both formed when two lines intersect. Look at that diagram. They are nearly identical. There's a black line and there is a green line that are crossing. Vertical angles, however, are angles. Vertical angles are the angles opposite each other when two lines cross. They are always equal. See this little curve that I have present in angle 2 and angle 3? Angle 2 and angle 3 are vertical angles. There would be your notation. Having that said, angle 1, and I'm going to mark it with a double curve, and angle 4 are also vertical angles. Vertical angles are formed when two lines cross. There are the angles that are opposite each other. Vertical angles are never adjacent. They can't, by definition, be side by side because they have to be vertically across from each other. Linear pairs. Linear pairs are adjacent angles, meaning they have to be side by side, that form a line. Here's one particular diagram of two lines intersecting, but a linear pair could also look, for instance, like this. Let me put some points on here so I can talk about it. I have two angles that are adjacent, meaning they are side by side, share a side, share a vertex, and when it says they form a line, together they create that line, which is 180 degrees. Couple different ways. Well, actually, one way to notate it is going to be like several of the others. Angle whatever and angle whatever are a linear pair. So angle 1 and angle 2 are a linear pair. No short abbreviation, which kind of stinks because there's always a lot of linear pairs. So 1 and 2 are linear pairs. They're side by side, they make a straight line. Angle 3 and angle 4 are a linear pair, form a linear pair. I can go the other way. Geometry stinks sometimes because there's lots of ways to see something. I could go, I need another color, red. I could go this way, and I could look at angle 1 is butted up against angle 3, and together they form a line. Angle 1 and angle 3. For purpose of your notes, it's probably not worth writing every single one of them down. You can if you want to, write tinier, you need a little bit of space. But just recognizing that when two lines cross, there are really 4 pairs of linear pairs. The other set that I'm leaving out here is going to be 2 and 4. 2 is right here, it butts up to 4, they make a line. Angle 2 and angle 4 are a linear pair. Same kind of goes for this example that I had created. I have a linear pair here and a linear pair there. So vertical angles, linear pairs are going to be the harder ones to see because they look so different, but they look so similar yet are so different at the same time. Vertical angles are vertical, they're opposite each other. Linear pairs form a line when they're shoved up together side by side. And I believe that's it for today. Thank you so much. Let me know if you have any questions in class.